Determine whether Rolle's theorem can be applied to the function on the closed interval. Okay, so let's look at, just take a moment to go back and look at those theorems. Okay. Rolle's theorem has to be continuous and differentiable. And f of A has to be equal to f of B somewhere on the interval. And that means there's at least one place where the derivative is equal to 0. So in other words, the secant line, the slope of the secant is equal to the slope of the tangent. Okay. So first one, determine whether it can be applied. If it can be, find the value C that satisfy the theorem. Okay, so is f of x continuous? Yes. Is it differentiable? Okay, f of x is continuous and differentiable on the interval -2 to 5. Yes, ma'am.
On the MPX theorem, do we have to write the steps to prove it being like
no?
So we can just state it?
You can just state it.
Okay. Like differentiability, the only way I really know is if like I graph it on my calculator and if it's continuous.
Right. It's not going to be differentiable. If it's a piecewise function where it's discontinuous, it's not going to be differentiable. Or if it's a function like an absolute value, something that has a cusp or a point. Yeah. Yep, that's absolutely right. Okay, so now what do we have to do? Yeah, first of all, let's figure out what f of -2 is. Right? And again, you can use your calculator for this. Let me see, that's going to be 4 plus 6, so that equals 0, right? F of 5 is 25 minus 15, 10 minus 10, which equals 0. Therefore, f of -2 equals f of 5, right? So that's the next part about Rolle's theorem. It's continuous, it's differentiable. F of -2 equals f of 5, right? Remember, we looked at this the other day, right? The formula, the definition, right? We're working on the interval from A to B, and we're looking at f of A, f of B. So we're looking at the endpoints. It's the endpoints that we're doing, okay? Okay, so now we've got to find where f prime of x is equal to 0. So we're going to differentiate this. So we get 2x minus 3, and we're going to set that equal to 0. We get x equals 3/2. So at x equals 3/2, f prime of x is equal to 0. Okay? And we can just say, therefore, Rolle's theorem applies. Okay. How about number 2? So an interval from -1 to 1. Any thoughts? No thoughts? Okay. Since this is not just a basic polynomial, I am going to look at it on my calculator. All right, so we're looking at x to the 2/3 minus 2. And we're going to go -1 to 1. Okay, so it looks to me like we're going to have a problem right here at x equals 0. Let's see. And we can see it better when we zoom in a standard window. So we have a cusp here, which means it's not differentiable at x equals 0, right? F of x is not differentiable at x equals 0. Therefore, Rolle's theorem does not apply. I guess just to be extra safe and careful and clear, I'm going to state that 0 is between 1 and negative 1. Okay. Okay? How about number 3? Is that differentiable and continuous on that interval? Yeah. So f of x is continuous and differentiable on open interval 0 to pi. Okay. Okay, then what do? We have to show f of a equals f of b, right? So f of 0 equals sine of 0, which is 0. F of 2 pi, well, we know that 2 pi and 0 are the same place, also equals 0. Therefore, f of 0 equals f of 2 pi. All right, so that's the first two conditions that we're verifying. So now we're looking for that value where the derivative is equal to 0. So f prime of x equals cosine x, right? So we're going to do 0 equals cosine x. So x equals, this is in radians, so it's going to be pi over 2 or 3 pi over 2. It's where the x value is equal to 0, which is on the y-axis. So if you get stuck and it's a calculator problem, you can do your inverse cosine, right? Inverse cosine of 0. Sorry, I got to put it in degrees. And we get 90, right? Now it's only going to give you the first quadrant results. So you have to know your trig, okay? You have to know your unit circle. Okay, so here Rolle's theorem applies. Okay? Number 4, so natural log function, okay, so that is continuous and differentiable, but that's probably one of those ones that you're not going to be 100% confident about. We didn't spend really any time graphing logarithmic functions. I know logarithms are inverse exponential functions, but let's take a look at it anyway so we can feel better about it. Okay, we're looking at x minus 2 natural log of x. Okay, I'll graph it on just a standard window. Okay, so this says on the interval from 1 to 3, so that clearly is continuous and differentiable. So f of x is continuous and differentiable. Make sure that you specify that it's on the open interval 1, 3, right? Okay, what next? F of 1 equals 1 minus 2 natural log of 1. So that's 1 minus 2. What's the natural log of 1? 0. 0. So this equals 1. F of 1 equals 1. F of 3 I'm looking at 1 minus 2 natural log of 3. Okay, I'm pretty certain that that's not going to equal 1, because in order to equal 1, this would have to be 0, right? So I don't even need my calculator. I just know that this does not equal 1. Does everybody understand my reasoning there? Okay. I know the natural log of 3 is not going to give me a 0. And if it's not a 0, then I'm not going to get 1 as my f of 3. Okay, so f of 1 does not equal f of 3. Therefore, we're going to say, f of 1 does not equal f of 3. Therefore, Rolle's theorem does not apply. There we go. I should say on 1, 3. Okay? We good with those 4? Okay. Let's see. Determine whether the mean value theorem applies. Okay, if so, find all C. Okay, let's look back at the mean value theorem. Mean value theorem. We're continuous and differentiable. Which one is just continuous? The intermediate value theorem. Intermediate value theorem is just continuous. Okay, the mean value theorem. We're continuous and differentiable on the interval. There is at least one number where f prime of C equals the average rate of change. Okay, so let's look at number 5. Okay, is this continuous and differentiable? Okay, f of x is continuous and differentiable on -1, 1. Okay, so we have to do f prime of x, and that's going to be 3x squared minus 2x minus 2. And then we're going to, I'm just going to do a different color for you. Then we're going to do the average. So we're going to do f of 1 minus f of -1 over 1 minus -1. Okay. Let's see, f of 1, 1 minus 1 minus 2. So that's -2. F of -1, that's -1 minus 1. So that's -2 plus 2. So I think it's 0, right? Okay, so this equals -1. I'm going to put it in my calculator just to show you, right? So in the calculator section of your test, I make it a practice of right away putting the function in my y1. It only takes like 10 seconds, maybe 5 seconds when you're using your calculator. On here, it takes longer, but to type this in, it's very quick. And that can ultimately save you quite a bit of time later on. Okay, so I've got it in my calculator. Take a real quick look at it. Okay, we're good, right? So now I'm going to do f of -1, I'm sorry, f of 1 rather, minus -1. It takes much longer on this screen, I'm sorry. Okay, and then we're dividing that by our 1 minus -1. Okay, so we get -1. Yes, Gabby.
Wait, so you can just put it in like that and it'll
Yes,
plug it in yourself?
absolutely. That's why I said do it on your calculator if it's a calculator section Save yourself a lot of time, right? The other thing is, in a high stress situation, we make silly arithmetic mistakes, right? And we've seen that. We see that over and over again. We're so focused on the calculus that we make mistakes like -1 to the third is -1. Like we might make that a +1, right? So use your calculator if you're allowed to use your calculator. Okay, as long as if you know how to. All right. Okay. So now what I'm going to do, I'm going to do -1 equals, because this is -1 is my AROC, my average rate of change. This is my f of b minus f of a over b minus a, right? Everybody with me on that? I just did, come on, there we go. I just used my calculator to figure out that part right there, all right? And we're setting that equal to the derivative, which is 3x squared minus 2x minus 2. Again, if it's a calculator section, put it in your calculator, okay, and calculate the intersection, right? If it's not a calculator section, okay, we're going to add 1 to both sides. So this is going to factor. Okay, it's going to factor like that. So x is equal to -1/3 and +1. Okay. Now here's the trick. And I'm telling you, your AP exam will do this because they're a bunch of cranky little old ladies. That's my theory anyway. They're probably not, but that's my theory. Okay. Go back to your definition, right? That open interval and that closed interval. It's continuous and on the yikes, speak English. It's continuous on the closed interval AB, but everything else is an open interval. It's differentiable in the open interval. Our C falls on the open interval. So if we look at our answer here, we found 2 points. We found 2 points where the average rate of change and the instantaneous rate of change are the same. Well, one of those points is the end point here on the open interval, which means that point is not one of the points we can consider. So we're going to say, therefore, at x equals -1/3, the mean value theorem applies. Okay, and we'll just make sure that we state that -1/3 is between 1 and -1. Okay, I want to just look at the graph of this one for a moment so you can see what's happening. Okay, let me just change the window to -1 to 1. Okay, there's my window, right? We're looking at where the average rate of change, let me see if I can sketch this over here. Okay, here's my graph. -1, 1, and it is going through 0, 0. It's roughly something like that, okay? So what we're seeing between -1 and 1, is that right? I've got a slope of, I'm not drawing it very well. This had the slope of that secant line is -1. Okay, the slope of that secant line is -1. So what we're looking for is that point, which happens to fall at -1/3, where the slope of the, let me just exaggerate this curve so we can draw it better. Okay, f of 1 was -2, right? f of 1 is negative 2, and f of negative 1 is 0, right? What's f of 0? 0. Okay. So I think the curve goes like this. Okay. Does that make sense so far? Okay, that's what my f of x looks like. Now the slope of the secant line between negative 1 and 1 is negative 1. The slope of that line is negative 1. The mean value theorem tells me there's some place in between where the slope of the tangent line is going to be parallel to that. Well, it turns out that it's right there at negative 1/3. So right there at negative 1/3, the slope of that tangent line is going to be the same as the slope of that secant line. That's what's happening with that curve. It's kind of hard to see on the calculator unless you just kind of distort it a little bit, right? So if I were to change my window, let's do y max be negative 2 and y min negative 2 and y max positive 2. Now you can see it a little bit better. So sometimes you just have to kind of distort your graph a little bit so you can see it better. Zoom in a little bit. Yep.
When you're writing it like back on the other thing, what do you put before there?
What do I put before what?
Like therefore, this is like therefore. I don't know. Yeah, I know, but like, do you not have to write it? Majority whether it's continuous differential or differential, which is like the 3 points.
Right. Does that make sense?
I was just wondering what it said therefore.
Okay, so because, right, this part is satisfied, this part is satisfied, and then the last part where we're setting them equal is satisfied. Since I've satisfied all three conditions, I then said, therefore, at this point, the mean value theorem applies. Right? If it's easier for you, you could do it in parts, right? Number 1, f of x is continuous. Number 2, f of x is differentiable. Right? Number 3, f prime of x is equal to, make that a c, sorry. F prime of c is equal to f of b minus f of a over b minus a. Right? But of course, you have to show the work for this part.
But you wouldn't include that if we find the same.
We don't have to restate it, no, because we've stated it elsewhere in the problem. Okay? Yeah, we don't have to restate it. So since we've shown all three of these conditions, either stated it or shown it, we can then say, therefore, at this point, this is because it asked for the c value where it applied. At this point, the mean value theorem applies, right? Because the problem specifically said, first off, does the mean value theorem apply on that closed interval? And if so, find the c value where it does apply. Okay. Okay. You're not going to see a whole lot of these on your AP exam, not where you have to write it all out like this. You will see a few multiple choice questions where, in order to answer the question, you have to determine whether or not that mean value theorem applied. Okay. So it might simply say, at what x value is the tangent equal to the slope of the secant, okay? Okay, the next one. Is this continuous and differentiable? Yes, okay. So f of x is continuous and differentiable on negative 6, 3. Okay. I just did all of these problems and I discovered a mistake in the way I'm stating that first statement. Anybody see that mistake? Yeah, if you look at our definition, these are the little things that they take points off, and it's very frustrating because you completely understand. It has to be closed bracket for continuous and open for differentiable. So we have to restate this. And I see. It's so frustrating because you completely understand and know what you're talking about. But they'll take points off. Continuous on negative 6, 3, and differentiable on negative 6, 3, the open interval, right? Did I say that right now? Yeah. Okay. Okay. So let's do f of negative 6 minus f of 3 over negative 6 minus 3. I'm going to put this in my calculator, square root. Right? Square root 3 minus x. Okay, that's what it looks like. We're going from negative 3 to 3. Okay, so now I'm just going to do my y1 of 3 minus y1 of negative 6. Okay, divided by 3 minus negative 6. Oops, oh my goodness, it's so hot on this. Let's try that again. Okay. And we get negative 1/3. Okay, negative 1/3. You do not have to show the arithmetic on your AP exam. Okay, you do not have to show the arithmetic on your AP exam. Okay, so now I'm going to do f prime of x equals, let me just rewrite this as 3 minus x to the 1/2, right? So that's going to be 1/2, 3 minus x, subtracting 1, so it's in a negative 1/2. That's the outside, and then we have to take the derivative of the inside, which is negative 1. Because we're subtracting 1. Okay, so we have negative 1 over 2 square root of 3 minus x. Everybody understand that part? Okay, so we're going to do negative 1 over 2 square root of 3 minus x equals negative 1/3. All right, I'm going to cross multiply. So I get negative 3 equals negative 2 square root of 3 minus x. So divide by 2, so we get a negative 2, so we get 3/2 equals the square root of 3 minus x. So we're going to square both sides. 9 over 4 equals 3 minus x. I'm going to subtract 3, and I'll just use my calculator to do that real quickly. So we get negative 3/4 equals negative x. So x equals 3/4. Okay, let me just show you a shortcut way of solving this equation. Okay, this equation here. Since they both sides at equal sign have a negative 1 in the numerator, we can take a shortcut and we can just set the denominators equal to each other. 2 square root of 3 minus x equals 3. Okay, so that's a little bit of a shortcut. Okay, so we have continuous, differentiable, and we just found the c value, right? So we're going to say, therefore, at x equals 3/4, and by the way, 3/4 is between 3 and -6. Right? Therefore, at x equals 3/4, the mean value theorem applies. The mean value theorem we can abbreviate as MVT. Okay? Yes, because the abbreviation is almost always used. Okay, you're going to see it all the time. Okay, I'm not going to continue going through all of them. Let's say number 7. That is continuous and differentiable. And we're going to find that the x value is the square root of 3/2.
I hope like algebra we can't have a square root on the bottom. If he says they let you leave it or can't.
They let you leave it.
Okay.
Yep. Yep, I'll get there. This is an absolute value function, which means it's not differentiable, but be careful. Look at the interval, okay? Don't just assume right away, because it depends on where that absolute value does its thing. But in this case, this absolute value is going to move over to 1/2 where the vertex is, so it's going to be on there. But double check yourself, because, let's see here, absolute value of 2x minus 1. Don't automatically assume, right? So in this case, we're looking from -2 to 3, and that point is there. But if I was looking at 1 to 5, it would be differentiable and continuous. So be careful. Pay attention to where that vertex is, to where the point is on your absolute value. Yes?
So can you tell if something's like differentiable or not by like not looking at a calculator?
In this case, I could. And you should be able to also, but it does take a certain level of thinking. Okay, I know that absolute values in general have that point, right? And I know that by my graph transformations, this absolute value is going to move the vertex 1/2 to the left. Since it's moving the vertex 1/2 to the left from its original position of 0, 0, the vertex is going to be over there at -1/2, which falls on that interval. So because that -1/2 falls on that interval, I know that it's not going to be differentiable on that interval.
Differentiable means like there can't be like a 0 in there?
There can't be a point or a cusp or a discontinuity. Okay. Question?
It be shifting, right?
It is shifting right, thank you. It's plus. Thank you. I wrote 1/2, but I said negative over here. That's weird.
Wait, so differentiability is like different from the continuity?
Yes, differentiability is different than continuity. Okay. Okay, so this one, the mean value theorem is not going to apply. Number 10, the mean value theorem, number 9, the mean value theorem does apply, and it's going to be at x equals negative square root of 1/3. Okay, number 10, yeah, okay, let's look at 10 together. So it is continuous, right? It's continuous on closed interval 1, 2, and it's differentiable on the open interval 1, 2. Okay. F of 2 minus f of 1 over 2 minus 1. So let's put this in our calculator. x natural log of x. Okay, take a quick look at it. Okay, we're going on 1, 2. So now that I took a general big look at it, I'm going to just change this 1 to 2. Okay, that's what I'm looking at. Okay, so we're doing f of 2 minus f of 1. So y 1, 2 minus y 1, 1. Okay, and I'm dividing that by 1. So that's fine. Let me just convert this to a fraction. Okay, it doesn't convert to a fraction. All right, so that means I need to go back and I need to do it by hand. Okay. Right. So we're going to have 2 natural log of 2 minus the natural log of 1, which is 0. So this is 2 natural log of 2, and it's over 1. All right. So I'm just going to kind of highlight that for now so I don't lose it. F prime of x first times the derivative of the second, and the derivative of the natural log of x is 1 over x, plus the second times the derivative of the first, which is just 1. So the natural log of x is 1 plus the natural log of x. I'm sorry, the derivative of f of x is 1 plus the natural log of x. We need to set these two equal. So we've got 1 plus the natural log of x equals 2 natural log of 2.
Attention teachers and students, at this time, can I please have my helpers for math this morning make your way to the church?
Don't close up if you're not going.
And your phones and all outerwear in the current classroom that you're in. Thank you.
Okay. All right, so we're trying to solve for x, okay? So we've got the natural log of x equals 2 natural log of 2 minus 1. Okay, that is an actual constant. All right. So this gets a little bit tricky.
I did find it.
Huh?
I changed natural log of 1 to natural log of e. And then, yeah. So then.
Where'd you get natural log of 1? Oh, you changed the 1 to the natural log of e.
So then I did the product of the natural log.
Okay, you can do that. You can definitely do that. Okay. Okay, so you did natural log of x equals basically natural log of 2 squared.
Yeah, and then I was able to
minus natural log of e.
Well, I was able to do ex equals 2 squared. Because whenever you're adding, that's the same as taking the product.
Where are you adding?
Because I kept the natural log of e on the left side.
Oh, okay. Okay.
So that way I can just get rid of all
Good.
the natural logs.
Good. I like that.
So I didn't have to
So this is natural log of e plus natural log of x equals natural log of 4. 2 squared is 4, right? So now we can combine these. Natural log of ex equals natural log of 4, right? Therefore, ex equals 4, so x equals 4 over e.
That's how I did it.
Beautiful.
I
Okay.
only remembered that because I was helping Mason in his pre-calc and they were doing the logs and stuff, so then I just remembered
Yep.
all that.
Excellent.
The only way I was able to think of that one.
Okay. Very good. Now, if you put that in your calculator, and you could put this in your calculator and graph the point of intersection, that would be fine. You'd get approximately 1.4715. That's also acceptable to do it that way. Okay. Let's go back to our notes. Oops, never mind. Stay there on your homework. Sorry. Let's look at number 11 together. Mr. O ran the Disney Marathon in 2 hours, 18 minutes. Remember, a marathon is 26.2 miles. Okay, 2 hours, 18 minutes. That's really good. Isn't that really good?
2 hours is the world record.
Yeah. It's really good. Okay. I mean, it's not as good as Grace, but it's pretty good. Okay. Remember, a marathon is 26.2 miles. Show that at least twice he had been running at a rate of 11 miles per hour. Okay. So at least twice. So what theorems do we have? What would apply here? I have an average, right? He ran it in 2 hours, 18 minutes, so I can come with an average rate of change. I can come up with his average speed, can I?
Yeah.
So which theorem am I using?
The mean value.
Mean value theorem, where the average is equal to the instantaneous, right? So my average rate of change is 26.2 miles in 18 minutes. 18 minutes. That's not going to be a nice number, is it? 18 divided by 60.3. Okay. 2.3 hours. Okay. Which comes out to be 26.2. 26.2 divided by 2.3. 11.391. Remember, in AP Calculus, we always run around to 3 decimal places unless told to do otherwise. Okay, 11.391 miles per hour. Okay, that's his average velocity. Okay. Okay, so what does this mean? Show that at least twice he had to be running at 11 miles per hour. Think it through, right? If his average velocity is 11.391. Okay. First off, would this be a continuous function? Yeah. Yeah. I mean, well, it's not a matter that he doesn't stop, but he can't jump from one speed to another speed, right? He's not teleporting. Yeah. Right. He can't jump from.
I mean, you run a 2 hours, 18-minute marathon's pretty good. So
Yeah. I mean, even if, let's say that this represents his running, even if he stops, right? He's not going to all of a sudden pick up at a greater speed or a lower speed. Even if he stops, he's going to pick up at that same spot.
Well, like
So-
wavering a little bit.
Yeah, but it's going to be continuous. It's not going to be discontinuous. So it is definitely continuous, right? It's going to be differentiable. So let's think about the theorems that we know, right? What do our theorems tell us?
Do you also use the Rolls theorem on this? Or no?
Which one is it? Mean value or
Wouldn't it be the Rolls? Because at 2 points, if they're running the same exact.
that 2 points? That's the key right there. It says 2 points, right? So let's say that
You can't take the derivative if you don't.
here's my hours, here's my miles, right? Usually we're going to usually start off pretty fast, right? It's going to be kind of something like this, right? And then we sort of start to slow down, right? That type of thing is going on, right? Well, this says his average rate, it says that we have at least 2 points where he's running at 11 miles per hour. So what this is implying is that here's my 11.391. That's my average. It says that I'm doing something like that, where I've got 2 times where I'm running at 11 miles per hour. If it says I've got 2 times that I'm running at a rate of 11 miles per hour, that's the clue that I'm looking at Rolle's theorem, because it says I have 2 times where they're the same. Okay? So if I have 2 times where they're the same, then there's got to be some point where the derivative is equal to 0. How does that work? That's what where the derivative is equal to 0.
Wouldn't the derivative be equal to 0 at 11.39? That's like the highest, the maximum.
Well, no, that's the average. The drawing is deceiving. I'm sorry, the drawing is deceiving. That's the average. Could be going something like that, right? Could be doing something like that. Okay? But since there's 2 times, right? So we can simply say, we don't have to know where that point is. Show that at least twice he had to be running at that rate, right? So if he ran at 11.391 as my average, then that means he had to hit 11 miles per hour as he was speeding up to that value, right? And then he had to hit 11 miles per hour as he was decreasing back down to when he was eventually going to stop, right? Since 11.39 miles per hour is greater than 11, right? 11.391 is greater than 11, right? He must have been running 11 miles per hour as he increased his speed right? And then again, as he decreased his speed. I mean, that could very well have been at the very end of the race. But if he was traveling at 11.39 miles per hour at some point, because we know that at some point that average and that instantaneous had to be the same, then he had to hit that 11 on the way back down to when he stopped. Okay? Tricky one. That's the answer. That be the answer. Okay, let's go on to number 13. You see a lot of these on your AP exam. Okay.
I thought math wasn't word problems.
Math is word problems. The real world is word problems.
No, but like I didn't realize like for math like you would have a whole paragraph as an answer.
Yeah, because that's the real world, right? Algebra 2, and when you're just plugging and chugging and getting numeric, that's not the real world.
There's an answer. Like with this, it can be like anything. Kind of.
Yeah, that's true. Because you're not just plugging in and getting numbers.
Yeah.
You're interpreting what it actually means, and that's the reality. That's the real world, you know. Okay, contaminated water is being pumped from a retention pond. RT is the amount of water that is left in the pond. T is measured in hours. Okay, so RT is the remaining water. Okay. So always take a moment to look at these tables, right? If you notice, as time progresses, RT is decreasing, which we would expect, right? Using correct units of measure, find the average rate of change from t equals 3 hours to t equals 21 hours. This is, excuse me, this is a very common type of free response question. It's going to step you through the problem, right? In the beginning of the problem, we know how to do this. How would you do this? How do you find the average rate of change of R of t? Yeah, we're going to say AROC, average rate of change, equals R of 21 minus R of 3 over 21 minus 3. R of 21, that's 7,000 minus 17,000 over 18. And this comes out to approximately negative 555.555, right? Using correct units of measure. That means you are going to be scored for that unit. If you have the wrong unit, you're not going to get credit. So on the top is R of t. R of t is gallons. And on the bottom is t. T is hours. So this is gallons per hour. Okay. You should always get these questions right, because this is algebra. You should be getting this part correct. Estimate the rate that water is being pumped at 8 hours. Okay, the rate that the water is being pumped. All right, R stands for the amount of water left, right? So the rate that it is being pumped refers to the rate of change in the amount of water. Okay, so we're looking at R prime. R prime of 8. It says estimate. That's another clue that we're not going to have an exact derivative, right? When you have a table, you're estimating the derivative by taking the rate of change on a small interval, okay? T equals 8 is between these two. That's the smallest interval I can use. So an estimate of that, we're going to use the squiggly line, right? It's going to be R of 9 minus R of 6. Sorry. This is a very common type of problem on your AP exam. Free response question. And this should be a 9. Free response questions are worth 9 points. You should get all 9 points on this question. Okay? Because these are not real hard ones. Right? So when we're estimating the rate of change that on a table, that means we're doing the average rate of change on as small an interval as we can get. Okay? So R of 9, that's 14,500 minus R of 6, which is 16,000 over 3. And that comes out to negative 500. So we're going to say R prime of 6, right, is approximately negative 500, again, gallons per hour. Okay, I'm going to go back and read the question. Estimate the rate that the water is being pumped at t equals 8 hours. Use correct units. Explain what this value means in the context of the problem. Okay, so at t equals 8 hours, okay, the context of the problem, the contaminated water is being pumped out of the pond at a rate of What?
Approximately 500.
Right. At a rate of 500 gallons per hour, right? Don't put negative 500 there. The fact that it's being pumped out of the pond, that's the negative part because it's decreasing the amount of water in the pond, contaminated water in the pond. Okay.
But approximately, since
Um,
a derivative, or
yes, that's a good, let's say pumped out of the pond at approximately. Thank you. Approximately. Pretend there's an R there. Okay. 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 Is there a time on the interval from 0 to 24 such that R prime of t must equal negative 600 gallons per hour? Well,
is this intermediate value theorem?
why do you say it's the intermediate value theorem?
Because if we know something is negative 500, then you take one earlier and it's a higher number. According to IVT, and one's lower than that, and it's a continuous function. It has to go through that point.
Okay, so, excuse me. Thanks. Okay, so let's say we know that between 3 and 21, we're at negative 555, right? We know that at t equals 8, my r prime is negative 500. So your reasoning is absolutely correct, but I haven't shown that to be the case yet.
But if you choose a point like between 0 and 24, and we find out that's greater than negative 600.
Okay, so what we have to do is we have to find, okay, absolutely, good job. Okay, good job, Kaylee. So we know we're looking to see if there's a point where r prime of t is negative 600. So that means I already know at t equals 8 that r prime of t is 500, negative 500, right? So if I can find an r prime where we are, what am I looking for? Less than negative 600. So if I can find an r prime where it's less than negative 600, right? It looks to me like that first time interval from 0 to 3, right? R prime of 1, right? We could do anything between 0 and 3. So let's just do r prime of 1, all right? We can do, that'll be r of 3 minus r of 0. I could have done 2, by the way. Right? I'm going to pick something on that first interval because I'm looking at that first interval and it looks to me like that's going to be negative 1,000. So this is going to be negative 17,000. I'm sorry, not negative, 17,000 minus 20,000 over 3, which gives me negative 3,000 over 3, which is negative 100 gallons per hour. I could have done R of 2 because it would have been on that same interval, right? It says, is there a time, right? So R of t is continuous and differentiable. Let's see. Okay, R prime, R of t is continuous and differentiable. So what can we say? What's our intermediate value theorem say?
And you would do r prime of 1 does not equal r prime of 8. And then you would do negative 600 is greater than.
We don't have to.
but less than the other. So that shows that it's in between. That's when you do like the in between sums.
Okay, so if you look at our intermediate value, it says y is a number between f of a and f of b. There exists at least one number on the open interval such that f of c is equal to y. Okay, so we don't have to show that they're not equal. This is not the one where we have to show that they're not equal, right? So all we have to do is we have to say, excuse me, yikes. I just lost track of my what I was saying. We have to show that the negative 600 is between the negative 500 and the negative 1000. Okay, so 1 is between 8 and, did I do that right? 8 and 0. Okay. And then we have to show that R of 1 is less than R of 8, which is greater than R of 0, right? So we have to show that that negative 1000 is between negative 1000 what am I doing?
What did you just do?
Negative 600, sorry. Negative 600 is between negative 500 and negative 1000. Sorry, I wrote this wrong. Hold on just a second. I hear what you're going to say. Just give me a second. There we go. Okay. So we want to show that the t that we found, right, is going to sandwich that negative 600, right? We want to show that that negative 600 is between the one that we found on both ends, right? So we want to show this right here. And then we're going to say, therefore, by the intermediate value theorem, there exists a C such that R of C is between negative 500 and negative 1000. Okay? So we want to show that that number falls on that, in that range or on that interval. And then we can say by the intermediate value theorem, then there has to be a value in between. Okay? It's continuous, it's differentiable. And it falls between those values. I think I better stop talking. Okay. All right, these get tricky, but we're going to do a lot of them, so don't worry. Okay, just stay here until we're dismissed, and you're going to leave your cell phones here. All right.
Disregard that bell, thank you.